Ladies and gentlemen, Dr. Nadir Ali.
I guess people are filtering back in from the break. So I have a very exciting talk that even the group that has come with me have never heard before. I spent long and hard trying to prepare for this. What I'm going to talk about is LDL cholesterol and how it relates to insulin resistance. So this is a quote from USDA, from the American Heart, that says that intakes of dietary fat and cholesterol are the major determinants of heart disease and diabetes. So these are the two major causes of death and morbidity in the US. And in order to improve from this, it is recommended that we reduce the intake of fat from 40 to 20% and intake of saturated fat to about 7% of our calories. So I used to say this also before, and I felt bad about that right now. But if something like this was told to George Bernard Shaw, who's out there, he would say, no diet would remove all fat from your body because your brain is almost entirely fat. Without a brain, you might look good, but all you could do is run for public office. So I'm tag teaming with Dave Feldman. He's going to come here and talk about cholesterol as well. And there is not much of an overlap between his talk and mine, except for maybe a few minutes. So what we're going to do is to do a deep dive into the functions of LDL cholesterol and see whether is it just cholesterol, because I want you to, when you think about cholesterol, I want you to think about it as lipoproteins. And that lipoprotein word is a little mouthful, but at the end of this talk, you would say, hey, I can see and tell you what that means and how it relates to cholesterol. So there are many functions of LDL cholesterol. They are listed on that slide. And I don't want you to get caught up into it because I'm going to dissect each and every one of this in a way in which a layperson can also understand. So cholesterol and triglycerides are fat. And fat does not dissolve in blood because our blood is watery. So if you take a beaker of water and you put oil into it, it's not going to dissolve. And the body has to come up with a smart and ingenious way of packaging the cholesterol and triglycerides so that it can be carried in the bloodstream. So the question is that why does our body need to carry cholesterol and triglycerides in our blood? And the reason you have heard from many speakers is that triglycerides is an important energy delivery system. So since it doesn't dissolve in blood, you can see out there on the slide, it has a lipoprotein is created, which has an outer cover. And the outer cover is made of phospholipids and proteins so that it can function in many different ways in signaling with different cells, in dissolving in blood, and being transported. And the cargo of this lipoprotein is cholesterol as well as triglycerides, which you see inside the lipoprotein. So I'm going to focus on the endogenous, that is the liver pathway through which we transport fat. Dave Feldman is probably going to cover a little bit about how when we eat fat, it's placed into a different set of lipoproteins, which are called chylomicrons, and transported that way. So the liver makes VLDL molecule, which is the father of the LDL molecule, and it is packed with both cholesterol as well as triglycerides. So the primary reason why we make this is because we need to supply energy, and as you can see out on the slide, the heart needs energy, the fat cells can store energy, the muscles need energy. So the VLDL is circulating, getting attached to these areas, and then transferring the fat energy, which is triglycerides, into cells that need energy. And then once it does that, once it dumps the triglycerides, that's when it becomes the LDL, and that's the cholesterol-rich molecule, which is called the LDL particle. So the primary job of VLDL and LDL is to supply energy to our cells so that they can get energy. Now, as we evolve, we don't carry too much storage of carbohydrate in us. If you were to drain the entire blood from my body, you would find about a teaspoon of sugar. And our liver can store about 100 grams of sugar, which is not very much. The muscle can store about 300. So altogether, we have probably a little bit, about a pound of carbohydrate. And you can burn through that pound of carbohydrate within half a day for a half a day of activity. So the total carbs that we can store is only about 100 grams, because the carbohydrate that is available in the muscles is reserved for the muscles. It cannot be used by the rest of the body because we lack an enzyme to use it. On the other hand, as you can see out here, we can store roughly about 63 pounds of fat. And the pounds of fat that we can store has increased. Out there in 1960s, the average male was about 165 pounds. Now we are close to 200 pounds. So we are carrying a little bit more fat now than we used to carry before. So we have tremendous fat energy. So one of the concepts that I want to dispel is that high levels of LDL cholesterol are bad. And one of the ways I can dispel that is through this study. So they took a group of normal healthy volunteers, and they told them that you cannot eat for 7 days. So they had a water fast, water and salt fast. And for 7 days, they did not eat any food. So what do you think happened to the levels of LDL? Mind you, when you go back a few slides, you see that you can burn through carbohydrate stores within half a day. At the end of half a day, the way you're going to supply your body with energy is through fat. So the LDL, which is the low-density cholesterol, was at about 112 at the beginning of their fasting and went up to about 190. So there was a 70% increase. So what I want to tell you is that the LDL molecule is homeostatically regulated. It's regulated in the way through energy needs of the body. And that is something that the medical profession really fails to understand and the general public fails to understand. All right, now, have you heard about CoQ10? So what CoQ10 is that it is the spark plug that drives our muscles. So without a spark plug out there, an engine will not work. And similarly, we have an engine in our cells which is called the mitochondria, which you see on the left side of the screen. That is my left. And the mitochondria is the place where you can take sugar and fat. It gets converted into a smaller molecule. And that is pushed through the mitochondria for us to be able to get energy. That is, it converts fuel, which is fat and carbohydrate, to energy. So you can see that although this looks a little bit scientific, it's very simple in the sense that there are a set of chemical reactions that the mitochondria does. And at the end of those chemical reactions, it's producing an energy currency, which is called ATP. So you see those ATP molecules happening out there. And that's just nothing but horsepower that we can use. So it would be surprise you to know that CoQ10 is a cholesterol product. It comes from the same pathway through which you make cholesterol. So this group of experimenters did the study in which they looked at 4 different groups of rats, the same rats divided into 4 different groups. One was the placebo group. Another group was given CoQ10. The third group was given a statin, which is called atorvastatin Lipitor. Statins reduce cholesterol levels, but they also reduce CoQ10 levels. And to the fourth group, they gave both the statin as well as the CoQ10. And they put them through a series of studies for 22 days. And one of them is that they weighed them. They put them through this rat exerciser, which is called Rotarod, which you see in the middle of the slide. And also they did some blood work. So When they started weighing the rats at 14 and 22 days, what you find is that the atorvastatin rats had a significant amount of muscle loss. Because of muscle loss, they weighed less. Whereas the rats that were not given any drugs or were just given CoQ10 had weight gain because of muscle mass gain. The rats that were given both the atorvastatin and the CoQ10 had a little bit of weight gain from muscle gain, but not as much as the control rats. Now, if you deprive the muscles of CoQ10 and the animal is forced to move, would you have muscle damage? And what you see out here is that you are checking the amount of creatine kinase, which is a muscle enzyme, in the right of the screen. And you can see that the groups that were given atorvastatin had damage to their muscles compared to the groups that were not given the drug. The CoQ10 could attenuate the damage. There is another muscle enzyme which is called myoglobin, and the levels of myoglobin in the rats that were given the statin were much higher. So this is clear-cut evidence that there is muscle damage when you take statins. Now, what about exercise performance? So these rats were put on that rotor rod, and these experimenters were good at looking at that. And you can see that the group that had the biggest decrement or reduction in exercise tolerance significantly was the atorvastatin group. So you can show in a rat model that given these cholesterol-lowering drugs that humans use will reduce exercise performance and lead to muscle loss as well as reduction in their muscle mass. So now what about humans? Is there evidence in humans that this happens? So this is the effect of statins on skeletal muscle function. It was done in a 6-month time frame. So I want you to understand that many people who take statins take it not just for a few days or 6 months, they take it for 40 years. And this was assessed not in people who have heart disease, this was assessed in healthy people. So you got to take these two factors into account. And the third factor that you need to take into account that's done by Dr. Thompson. And if you look at the writing beneath his name, he's paid by almost every single pharmaceutical agent, and he speaks for them. So obviously, a researcher would have some degree of bias. So you would expect that his study would come out favorably saying that statins don't cause any damage. But what you see out here is that on the side which says 55 years and above, so people who are at risk of reduction in mobility and muscle damage are older people because they have lower muscle mass. And what you saw is that when you looked at activity counts, in other words, there was a device that was placed into them that measured how mobile and how active they were throughout the day. And you can see that the greatest reduction in activity counts, the greatest reduction in exercise was happening in the older group that was taking the cholesterol-lowering drug. So amazing information that is not really put out for the general public to see. What about muscle damage? So here are muscle enzymes on the near side of the screen. And what you can see here is that the muscle enzymes went up in the treated group with the statins. And on the right side, you can see that the liver enzymes also went up, saying that there was both muscle and liver damage. All right. So now we are moving over from muscles to the brain. The brain has a lot of cholesterol. The cholesterol provides structural integrity to the brain. 25% of the body's cholesterol is in the brain. The nerve receptors through which our brain communicates, which is neurotransmitters and the chemicals that sit on the nerve receptors, depend on cholesterol to provide structural integrity to them. So when you give somebody cholesterol-reducing drugs, or when you look at cholesterol in general, does cholesterol have any relationship to brain function? So this is a fascinating study, which is called the Lothian birth cohort. It was done, this cohort started in 1936. Lothian is a region in Edinburgh. That's the Edinburgh Castle out there. So about 1,000 men and women were taken. And in 1947, these boys and girls went through a cognitive function test, and they were followed for all this time. So this is an amazing group of people that we know that had cognition tests done at age 10, and they were brought back at age 70. And what we were trying to measure is cognition and cholesterol and brain function. So they were looking at three things. What is the level of cognition in these people? What is their cholesterol levels? And are they on statins or no? So let's go through this. This is very fascinating. And what we find out here is that you can see that I have divided this group into low, intermediate, and high cholesterol group. And you can see that the high cholesterol group, which is shown there in gray, it's predominantly women. Women tend to have higher cholesterol as they get older, okay? Whereas men tend to have lower cholesterol as they get older because the men, which are shown in blue, have low cholesterol. Professionals, people who were at high levels of success, had greater amount of cholesterol. Managerial people also had greater because they're the next step down. Whereas when you look at people who had non-manual and unskilled labor, you see that the highest cholesterol group, they represented a lower portion of those. What about physical activity? The people with the most robust physical activity had high cholesterol levels, as you can see that in gray, whereas people with lower physical activity had lower cholesterol levels. Now, what about high blood pressure? So it would surprise you to know that people with high cholesterol had lower tendency to have high blood pressure, as you can see in the gray bars out there. What about strokes? People implicate high cholesterol as causing strokes, which is some of the most ludicrous things that I have heard. In this group, having high cholesterol was the lowest risk of having stroke, 2% versus 50%. What about heart disease? The people who had the highest cholesterol had the lowest incidence of heart disease. All right. Now, what about brain function? You can see out here the estimated brain function as general ability, how you process information, how you look at memory. And the same pattern held through. People with the lowest levels of cholesterol had the lowest mental skills that you could think about, and people with the highest levels of cholesterol had higher mental skills. Okay, verbal ability is another one here. People who had better verbal ability had higher cholesterol levels. IQ at age 70 was higher if you had higher cholesterol levels compared to lower cholesterol levels. And now we move on to an area in which I am on a little bit of water. I'm treading water. And you can see that we are looking at cognition and statins. About 300 of these patients or people were on statins, 700 were not. And amazingly, the people who were on statins had lower cognitive function in terms of general ability, processing speed, memory, compared to the people who were not on statins. What about verbal ability and IQ? The verbal ability and IQ were similarly higher in people who were not taking statins compared to people who were taking statins. Now, to provide fair balance, I have to tell you that IQ at age 70 depends on a lot of factors other than cholesterol alone. And I have elucidated them out there. It could be education, it could be many other factors, or it could even be IQ at age 11. But the important point out here is that if you go through epidemiologic literature, you will find a consistent pattern that people with high cholesterol tend to live longer. So I guess I went back. All right, now we're going to move to another little section, and the way I formatted the slides is inspired by Dave Feldman, who's sitting right in front of me out here. So if you have high cholesterol levels, does it help you prevent from having infections? So this is what the question that I'm exploring. And out here on the slide, you can see that these are bacteria which are called Staphylococcus aureus. And they do something very amazing, which is called quorum sensing. I want you guys to be with me because even though I'm giving technical points, I'm going to explain each and every one of these technical points. I'm going to carry you with me. So quorum sensing is like sending out a pilot to explore your environment. Just like if Trump is having a high-level meeting down in Singapore, he will send some pilot to see whether the environment is favorable. Similarly, bacteria, before they encroach an environment and want to multiply, they do what is called quorum sensing. So they send out this pilot, and you can see that the pilot is going into the milieu, and it comes back and tells them, hey, the environment is favorable, let us go and kill this host. So they start multiplying, and quorum sensing is established. That means bacterial virulence and multiplication increases. Now, does LDL, the bad molecule that we are trying to reduce, does it protect us from this? So there are research studies that have been done that show that LDL goes and takes out the protein that bacteria use for quorum sensing. And you can see out here that LDL goes and engulfs these molecules and reduces the chances of these bacteria gaining a foothold, and neutralization of bacteria is one of the functions of LDL, a factor that I did not know until I got into this field, and I'm a cardiologist. Now, what about inflammation? Inflammation is a hallmark of getting heart disease, and bacterial infection releases certain inflammatory molecules, which is called LPS and LTA, and when they are released into the circulation, it causes inflammation, like Gary Fettke shows in that nice diagram out there, and inflammation leads to cell necrosis and cell death. Does LDL help reduce inflammation? And you can see out here that LDL is coming here and engulfing these endotoxins and protecting the host or protecting the body from inflammation. All right, now we're moving on and trying to see, does cholesterol have other support functions? Does LDL have other support functions? Every cell in our body needs cholesterol. The membrane of our cells is lined with cholesterol that provides structural integrity. So if you look at this particular GIF file, you can see that as the membrane breaks, cholesterol is released, and this cholesterol gets picked up by the HDL molecule. Then comes the LDL, the bad molecule. It's supplying cholesterol back to the cell membrane so that cell membrane can be repaired. So how does it do that? Now, this may look like a complex slide, but it is very straightforward. Out here on the right of the slide, you can see that LDL gets into the cell. It gets into a vesicle inside the cell. And then the cholesterol inside that vesicle is released into free cholesterol. And through a series of amazing engineering steps, you can see that the cholesterol is sent back to the cell membrane, and it creates what is called these focal adhesions. Now, that may look like a big term, but basically it is giving the ability of the cell to cause cell repair. So what does that mean? So, and this is how I'm going to explain to you. If you have a blood vessel and it gets disrupted because of high blood pressure, because of damage, because of bacteria or whatever, you tend to have denudation of the lining of the blood vessel and you get a blood clot. Sometimes that blood clot can go to progression and close up the blood vessel and cause a heart attack. But there are times, as you can see on the right of the screen out there, that we have mechanisms to repair the lining of the cells. And does LDL help with repairing these lining of the cells? And this is what the slide is supposed to show in scientific form. When you have the presence of LDL, and I'll focus on to the right side of the screen, you are seeing that LDL, the cells are traveling much further, migrating much further because of focal adhesions, so that the damage to the lining of the blood vessel can be repaired compared to a setting in which the LDL is removed from the serum. These were experiments done in cell culture layers. So does repairing cell have anything to do with cancers? Because apoptosis and cell repair is one of the most important factors in which we can reduce malignancy. So what I find out here is that people who are given long-term statins, and I have a lot of research on this. So this is a group of people that have been given statins, women, and we have divided into the number of years that they were on statins versus the group that were not on statins. And what you see out there is that the group that were on statins, they got ductal and lobar cancer 2.5 times higher incidence compared to controls when statins were given for greater than 10 years. So there is plenty of evidence if you are able to look through literature, because the statin manufacturers, the medical communities try to minimize these findings because they're not explored very well, but if you dig through the literature, you can find it. Now, what about erectile dysfunction? So erectile dysfunction is a very important aspect, and not many people know that testosterone and estrogens are cholesterol byproducts. You get testosterone and estrogens from cholesterol. And amazingly, the testis and the ovaries are some of the few cells that cannot make their own cholesterol. So where do they get their cholesterol from? They get their cholesterol from the LDL molecule. So is there any evidence that people who are on statins will have erectile dysfunction? And again, this data is not gathered well because there is no incentive for a drug company to do a trial that is looking at erectile dysfunction with their drugs, because nobody will use it. So when you look at this, what we find here is that if you look at cholesterol or testosterone levels in people who are taking statins, there is a significant, this is on the left of the screen out there, there's a significant reduction in total testosterone levels in people who are on statins compared to people who are not taking statins. And then when you look at the French study, and the French look at sexual function much different than we do, I guess, so they gather this information. You're supposed to get a laugh from that, but it's okay. So what you see out here is that French gathered this information, and they said that a consequence of reduced testosterone may be erectile dysfunction. And you can see that the incidence of erectile dysfunction in this retrospective analysis was 10.6% in the statin users compared to match non-statin users. Now, Dave and I were looking at this slide. This is shifting gears and saying that if you have high cholesterol, does it kill you? A simple question. If you have high cholesterol, does it kill you? So this is a Norwegian study. 50,000 patients were followed for 10 years. Now, that's an amazing amount of information. 50,000 patients followed for 10 years. And what you can see on the left panel is that as you are going to the right side, cholesterol levels are increasing. So 5 millimoles, which is about 193 milligrams, is on the right side. 7 millimoles is on the left side. You have a line which says 1. So the low cholesterol people were normalized at 1. And as your cholesterol increased, if you were at higher risk of dying, you should see the line go above 1. But what you're seeing is that the higher the cholesterol, especially in women, and this is age-adjusted, the risk of dying goes down, not goes up. In men, it follows a little bit different pattern, but pretty similar. Now, when you look at heart disease deaths, which is on the right side out there, women still benefit. The higher their cholesterol, the lower the risks of dying from heart disease. In men, it remains somewhat flat. And that is a study that was done in 50,000 patients. Now, this is the Monica project, 2008, data gathered in different European countries. And damn the French again. They eat a lot of fat. And you can see 15% saturated fat. They have high levels of cholesterol. But when you look at heart disease death, they manage to look good. They smoke a lot. But when you look at their heart disease death rate, the death rate is much lower than the rest of the European countries that eat less fat and have lower amount of cholesterol in their blood. So, and I'm doing good with time. So drug company-sponsored studies, there are a lot of studies that tell you cholesterol-reducing drugs, statins, are very good. They are about 50% of American adults should be on it. But a drug company can do 10 studies and only show you the ones that have a favorable effect of the drug. They don't have to show you all 10. They can just show you one. Studies are done in about 1,000 centers in 25 different countries. And who is gathering the information? It is the drug companies. Who employs the statisticians to calculate the information? It is the drug companies. They employ ghostwriters to write the entire manuscript, give it to big physicians, and say, hey, let's put your name on it and publish this. So a while back, you may have seen this ad that came out saying, after a study called Ascot LLA, that Lipitor reduces the risks of cardiac event by 36%. And I got the inspiration for the slides from David Diamond. 36%. I want you to digest that information. 36%. Okay? So I said, where is that 36%? Roughly 10,000 patients, half of them given cholesterol-reducing medicine called statin. Their cholesterol was not very high anyway. And the other half were not given statins. And this information is collected entirely by the drug companies. So I'm looking at it, and I have plotted it a little different than what the drug companies would like you to do. But I said, absence of heart disease, death, and heart attacks. The number of patients at the end of 3.3 years who did not have a heart attack and did not die of heart disease. And what you see out there is that those two numbers are pretty similar, 98.3, 97.3. When you looked at heart disease death, there was no real difference. So I'm saying, where is the 36% benefit? And the 36% benefit is shown right there by the arrow where I'm showing. And the reason they are doing that is that they're saying that there is a 1% difference at the end of 3.5 years of you having a heart attack or dying by using this drug. And how can it be 1% and 36% at the same time? So the way they do that is that they do the statistical juggling. And I will show you that statistical juggling in a bit, is that they take that 1% difference divided by 3%, because 3% is the difference between the placebo group and 100% for no good reason whatsoever, and come up with a 36% difference. So when this ad came out many years ago, and if I had told you that there is a 1% difference by taking this drug, and it was almost entirely done in a way in which there was no government oversight, I wonder if anybody would have really taken the drug, and if Lipitor would have been the hottest selling drug, grossing the highest amount of revenue for the company. Okay, so this is another new group of drugs that is being imposed on unsuspecting patients. And these are called PCSK9 inhibitors. These are injections that you take in your thigh. And what they do is that they trick your liver into thinking that there is too much LDL, and the liver takes back all the LDL. And this was done, as you can see out there, in nearly 28,000 patients. 28,000 patients. 14,000 were given placebo, they were given just a dose of cholesterol medicine, but not this powerful one. And 14,000 were given a very powerful cholesterol-lowering medicine, which is the PCSK9 inhibitor called Repatha. And their cholesterol levels went down to as low as 30 milligrams per deciliter. That is a dramatic reduction. If LDL cholesterol were the culprit, you should have seen that if you study 28,000 patients, that there should be some improvement in death rate. There was no improvement in death rate. In fact, more people died taking the drug than those people who did not take the drug, as you can see out there. So I have this to tell them from John Abrahamson. Dying with corrected cholesterol is not a successful outcome. So I want you guys to start eating like this. Lard, butter, all kinds of dairy products. There was somebody out here from Wisconsin. all the good meats, the fatty fish. Now, what will happen when you eat like this? What will happen is that your HDL will go up, the triglyceride, which is fat and blood, will come down, and inevitably, eventually, as you get healthier, your LDL cholesterol, which people are scared about, is going to go up. Now, you can argue that that LDL cholesterol that's going to go up is going to be the large and fluffy kind and not the small and sticky kind. But in my practice, I've been doing this for about 5 years. I see that eventually, as people get healthier, their LDL cholesterol goes up. On the other hand, the standard American diet is like this: a little bit of sugar, a lot of grains, this highly inflammatory vegetable oil, which is probably the worst oil you can cook with. I highly recommend that you watch Nina Teicholz's The Story of Vegetable Oils, and sugary fruit. When you eat like this, by the way, 60% of our calories come from this trifecta, which is grains, added sugars, and plant oils. So when you eat like this, your good cholesterol goes down, your triglycerides goes up, your LDL may go down, and in fact, polyunsaturated vegetable oils make your LDLs go down, but you get severe insulin resistance. Your insulin levels go up. So that is the paradox I'm talking about. Almost everything that you do to reduce insulin resistance is going to increase your LDL levels, and you're going to be scared. So insulin resistance is important. About 50 to 70% of Americans have insulin resistance. It's the major culprit behind all the diseases that we have, which is cancers, strokes, heart disease, diabetes. Maria talked about having PCOS, which is listed out there. High insulin levels also create toxic hunger. All right, so now I put the slide up, and especially inspired by Peter Ballerstad, who I see out there, another great man, my hero. So say, hey, doc, I don't eat like that. I eat high-fiber food. And the problem is that we are not designed to eat high-fiber food. If we were designed to eat high-fiber food, we would have a ruminant-like stomach with 4 stomachs so that we could ferment the fiber that we have. We are not even like the gorillas. The gorillas are called hindgut fermenters. Our digestion is acid-based. The ability for us to ferment fiber is very limited. Our colon size is 10% the size of our herbivorous ancestors. We don't have a fermenting vat, which is shown out there in pink, which is called the cecum. So the other problem is that when you go to a plant-based diet, you don't absorb certain key important nutrients because these are fermented in the hindgut, and you can be low on B12 and K2. So this, again, slide I took from Dr. Ballerstad. The apes practice this beautiful coprophagy. So next time your vegan friend says, eat like a mountain gorilla, thank you. So I'm still doing good on time. I'm surprised. So really, what I'm telling you is the story of the Lorax. So here is the little kid going out there and talking to the Onceler. And the Onceler is you, people out here in this audience. Dave Feldman, Peter Ballerstad, all the speakers out here. And these people, after having gone through all of the tumults of 50 years of obesity, diabetes, and damage to our health, are giving us a truffula seed. So, and this is what you have to do. You have to take that truffula seed in your hand and then recognize that there are benefits of eating the way we do, that there's benefits of high LDL, as we pointed out. You have better host defense because LDL is involved in host defense. It's a mechanism of energy delivery that Dave Feldman will tell us better than anybody else. It has role in cell repair, in apoptosis. We talked about CoQ10 and muscle function. That is important. You will be smarter and have better memory. And if you have high LDLs, as long as your triglycerides and HDL are the right kind, which means low triglycerides, high HDL, you will live longer. So instead of celebrating a high LDL, we moan it and we try to get it down. with medicines. So this is what I'm leaving you with. All of you have responsibility of changing medical school education. I went through an entire medical school education not knowing a thing about the functions of LDL and about lipoprotein metabolism. It's thanks to the work of Dave Feldman, who's showing the dynamic role of LDL and how it's homeostatically regulated, that I got interested in it. So we need more research on LDL, and we need to understand that pharmaceutical bias is permeated into the entire medical system. So this is who I am. I'm a whistleblower, and I am target of ridicule. This is amazing. It's never happened to me before that I finish exactly on time. So thank you.